Alright guys, we got our last little bit of stuff to do together, and then you'll have lots of work time. If you've been on it, you should have lots of work time, okay? So your binder, you should have filled out like this. Not filled out, sorry. In your binder like this. Left side, right side. The left side, that's what you're going to want to reference if you need to go study later. It basically describes what we just kind of worked through together and explored. The right-hand side, we're going to summarize now, okay? So, follow along. Let's get done. So, question 1. What are exponents used for in mathematics? And here's an example. You got your base, you got your exponent, right? Oh, 6 times 6 times 6. I think it got cut off there. Well, what are exponents used for in mathematics? Well, fill that out for number 1. Exponents are used to show repeated multiplication. I'm running out of space. Multiplication. Exponents are used to show repeated multiplication. For example, you should write this down. X to the 5th, well, that means x times x times x times x times x. 1, 2, 3, 4, 5 x's multiplied by each other. And it is going to get a little more complicated. We need to stretch our brains a little bit. So another example would be AB to the 21st. Oh, we have to write out 21 of these. No, we don't. We can shortcut it a little bit. Try this. AB times AB times AB. Oops, that's a bad A. Times AB. And put this. Dot, dot, dot. To show that that pattern keeps on going. Times AB. Now, you can't just leave the dot, dot, dot right there. Make a little note that says, if you had 21 of these, if you did it 21 times, that would also be a representation. Okay. All right, question 2. How are exponents related to those graphing stories that we did at the beginning of the year? Well, you remember exponential functions? Exponential functions. And those of you who, if you remember that, remember the graphs kind of look like that. They got really steep, really fast. Or I think on our quiz, we had one that shrunk also. Remember in those? Like the bacteria multiplying, it's doubling. It's times 2, times 2, times 2. That's exponential, repeated multiplication. All right? And we'll come back to exponential functions, exponential graphs later in the year. For now, here's what we need to remember. This is a summary of what we just did in the previous worksheet, okay? Use it for a reference right there. You don't write on the left side. You don't write on the left side. But we're going to do a couple examples on the right side, okay? Product law. Product means multiplication, right? The answer to a multiplication problem is called its product. So if you've got, look over here, a to the m times a to the n, you can add the exponents. We looked at that one earlier. Let's put an example here. Let's do one more example, okay? Let's make it a little more complicated too. What about like w to the negative 4? Sure. Times w to the 10th. Can you still add those together? Well, yeah, you've got the same base. These are both w's. So w to the negative 4 plus 10. And we can simplify that a little bit. What is negative 4 plus 10? 6. W to the 6th. All right? So you've got an example on the left-hand side. We did one more on the right. You have the ones that we did in the previous worksheet, okay? We've done a lot of examples. Let's talk about quotient law. Quotient, that references division, right? The answer to a division problem is its quotient. It's down here. Let's put it in green, right? Remember, quotient, you can subtract. Notice this little pattern. When you're multiplying things together, you add their exponents. When you're dividing, you subtract their exponents. Doesn't that kind of make sense? Like, multiplying and adding makes things bigger. Dividing and subtracting makes things smaller. I think it kind of makes sense. So let's do another example. Let's do another one with negative numbers, just because sometimes those are tricky, and we can look at one then, okay? Let's try like f to the third divided by f to the negative 2. All right, they have the same base, f, and it's being divided, so you can subtract those exponents. Now, two negative signs? Yeah. 3 minus the stuff on the bottom. That negative 2 is what was on the bottom, and we're subtracting it. Now, some of you already probably are saying, because you guys are, I know you like to say it, those two negative signs turn into addition, right? Minus a negative is addition. So f to the 6th would be the most simplified answer. Let's keep going. Power law. Now, power, right? Power law, when you hear power, think exponents, like exponents raised to more exponents. And we've got an example over here. All right, a to the m raised to the n power. So let's look at another one. What about like, and let's keep going with our negative number examples. That's kind of cool. How about like x to the 10th raised to the negative 2 power? X to the 10th to the negative 2. Well, look at the pattern on the other side and think about what we did. X to the 10 times negative 2, which simplifies to x to the negative 20th. That would be the most simplified, there we go, this most simplified answer. Okay, this inverse law, I don't think that came up on the packet we just did. We're not going to go into as much depth. I think we'll maybe do some more specific examples when I come back tomorrow. But, let's see, I need a better highlighter color. What do you want to use? Pink. All right. So, if you've got something with a negative exponent, like let's do an example over here. Maybe we'll do two examples. Like x to the negative 2. Sometimes we don't want to use negative exponents. Like it's easier to work with positive numbers, right? So the way we can deal with that is with an inverse. Now think of what inverse means. If you invert yourself, you just flipped over. That's what inverse means. You can flip it over, take it from, x to the negative 2 divided by 1, right? Dividing by 1 won't really change it. Flip that over. 1 over x, and since we flipped it, change that to positive. Let's do another one. Like what about let's do an even double reverse. 1 over z to the negative 3. How would we make that positive? Have a positive exponent. Use that inverse law. Flip it upside down and make the exponent positive. Z to the 3rd. And you can think about it as over 1, because that dividing by 1 doesn't change anything, right? Okay. Zero law. Let's just write that in words. Anything to the 0 power is 1. Anything. Anything. X to the 0 equals 1. AB to the 0 power equals 1. Like, smiley face to the 0 power equals 1. Anything to the 0 power equals 1, okay? If you're a little stuck on that, look back at the example we did before. All right, one challenge problem, okay? And this is what you'll see on your group collaboration work that you're going to turn in for a grade today. Try this. Let's kind of bring these rules together. 8a to the 4th, b to the 5th, I'm looking at my example here, 2a to the 1st, b to the negative 2. Let's simplify that. Oh, I need to move let's move up here. Let's simplify that so that all the exponents are positive and it's reduced as much as possible, right? It's good to condense things. I don't want to write that much. Let's condense it down. Well, 8 divided by 2, that gives you 4. And divided because there's a fraction bar, right? Fraction means divide. Now, we know this if you've got the same exponent, if you've got the same base, with different exponents and it's being divided, you can subtract those exponents. So, a to the 4 minus 1, right? The 4 was on top, 1 was on bottom. And b to the 5 minus negative 2, which is plus 2, like we just did up top. Simplify all the way. 4a to the 3rd, b to the 7th. That is the most simplified answer. We condensed it down, okay? All right, that's all the work we're going to do together. When we stop this video, you will be given this worksheet. All right? Here are the directions. Let me get our directions here. Here are the directions. This is I'm going to call it a quiz, but it's open notes. You can talk. You can rewatch this video. That's on Google Classroom. It's due at the end of the period. Work with your group. When you're done, staple all of your group's papers together. So I should get little stacks with 4 papers or maybe 3 papers stapled together. I'm going to pick one random from that group. That'll be the one I grade. And everybody in that group will get that grade. Okay? Do at the end of the period. Work together. Staple together when you're done. Staple your group's work together when you're done. Because one of those will be for a grade. You may use your notes, what we just did. You can talk, you can look up videos. The rest of the time is yours. Get to it.